The question is, what is the connection between statistics and hypotheses? How do statistics work to test hypotheses? Well, this summer an example came up that made me think about this. The shortstop for the Colorado Rockies, for the first 6 weeks of the season in 2014, had a batting average well over 500.
Whoa, that's pretty good.
In his own park. And a sports writer didn't think this was possible, and so he tried to find a different reason.
He was hypothesizing that there was something else going on?
Right. And what he hypothesized was that the shortstop must have been stealing the signs so he knew what pitch was coming.
The null hypothesis here is that really this guy is a good batter, and he is just able to hit 500 based upon his skill only. But the sports writer was suggesting that there's some other X, some other characteristic, some other variable that was influencing his performance. So the null hypothesis would be that there is no other X variable that's influencing his batting average.
Such as stealing the signs.
So you test that statistically by seeing if there's some other X that's influencing the person's performance.
So let's look at a specific example. Throwing a javelin after using one of 3 different training methods. So in this example, a researcher is going to have 3 groups. One is going to be throwing the regular javelin. One is going to be throwing a javelin that is lighter than average. And the third group will throw a javelin that is heavier than average.
Essentially, they're training with 3 different types of javelins. Is that it?
That's right. And then at the end of some length of time, the researcher will test the mean difference that each group can throw the javelin. If it happened that all 3 groups had the same mean distance, then the null hypothesis would be the answer to the question.
That is, there's no relationship between X, the method of training, and Y, how far you can throw the javelin. On the other hand, if there was a substantial, call it significant difference in how far they could throw the javelin dependent upon how they were trained, then you would conclude that there was an effect of manipulating the training method.
Now, it's going to be very rare that the 3 means would ever all be exactly equal. Even if there were no training effect, the means would probably be somewhat different. The question is the difference among the means too great to be believed that this is just a chance occurrence?
Essentially, there are some hypotheses that would be stated in this particular example with the javelin training methods.
Right.
There's a statement of the null hypothesis. There's no relationship between how far you throw the javelin and what method you use for training.
The statement of the research hypothesis would be that there is a significant difference among the means.
You'd actually test this with a one-way between groups ANOVA, which you'll learn about later on in the text. And based upon the results of the one-way between groups ANOVA, you would make a decision about the probability of the null hypothesis being true. And it's that probability that helps us make a decision about whether we continue to entertain the null hypothesis, there's no difference amongst the training methods, or do we reject that hypothesis and conclude
that there is a difference between the training methods in affecting how far athletes can throw a javelin.